Mod 5 will be dealing with the graphs of trig functions. In this first video, we are going to look at only the graphs of sine and cosine. When we graph trig functions, the independent variable is the angle measure, and the value of the function at that angle is the dependent variable. This means that the angle measures are plotted on the horizontal axis, what you traditionally think of as the x-axis, and the value of the function is plotted on the vertical, or what you traditionally think of as the y-axis. We're going to begin by graphing the sine function. When we want to graph the sine function, we are going to look at the values on the axes. So when theta is 0 here, theta is 0 degrees, what is sine? Well, remember that the sine is the y value, so the sine is also 0. Now we're going to go up to pi over 2. So our angle that we are talking about is pi over 2. What's the sine of that angle? What's the y value? It is 1. Come over to pi. That's our next angle that we're going to look at. And we look for the y value at that angle measure, and it is 0. Come down to 3 pi over 2 as our angle measure. And we always graph these in radians. And our value, our sine value, the y value, is -1. And then go back up to 2 pi now, and you are back at 0. So we have made one full revolution. And in doing this, we have done what's called one period of the sine function. The sine function has gone through every one of its possible values, going from 0 to 2 pi in one revolution. So let's set up our graph. Remember that the horizontal axis gets the angle measures. So we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. The largest answer that we had was 1, and the smallest answer that we had was -1. So let's plot our points. When the angle was 0, the value was 0. At the angle pi over 2, the value is 1. At the angle pi, value is back to 0. 3 pi over 2, we're down at -1. And then at 2 pi, we are back to 0. So now, if we connect all these values, this is what the sine function looks like. It has gone through every one of its possible values between 0 and 2 pi, so that's called one period. We could have continued doing this over and over and over again. We could have continued going in the positive direction. We could have gone in the negative direction. But what you need to know is this general one period length function for sine. Now that we have the graph in place, let's look at some characteristics of this graph. The period of the sine function. How long does it take us to go through one full cycle of this function? 2 pi. The amplitude. Amplitude means what's the highest and lowest that it goes. Notice that the highest it goes is to +1, the lowest that it goes is to -1. Amplitude is always positive, so the amplitude is 1. The domain. What x values get used? Well, this thing goes on forever to the right and to the left, so what x values get used is all real numbers, which we write as -∞ to infinity. The range is the y values. Notice that the lowest we went was -1 and the highest we went was +1. We always go from the smallest to the largest, so we go from -1 to +1. Both of those numbers are included, so we put square brackets around them to show that they are included. Now we're going to look at the basic graph for the cosine function. The cosine function, starting at angle 0, remember cosine is the x-coordinate. When we are at the angle 0, the x-coordinate is 1. At the angle of pi over 2, the x-coordinate is 0. At the angle of pi, the x-coordinate is -1. At the angle of 3 pi over 2, the x-coordinate is 0. And then going back up again to 2 pi now, because we've made our full revolution, our x-coordinate is +1. So our x or horizontal axis will have the same markings as it did on the sine function. And notice that our y values or vertical values all varied between -1, 0, and +1. So just like we had on the sine function, our highest value is 1 and our lowest value is -1. What's different on this function is that at the angle 0, we start up at 1. At pi over 2, we're at 0. At pi, we're at -1. At 3 pi over 2, we're back to 0. And at 2 pi, we're back to 1. So now, connecting all that, that is the basic cosine function. You must know the basic shapes for the sine function and the cosine function. Just like we did on the sine function, we're going to talk about these characteristics of the cosine function. The period, how long did it take us to get through one cycle of this function? 2 pi. The amplitude, the highest and the lowest we went was 1. Remember, amplitude's always positive. The domain, as we go to the right and left, this thing would go on forever, so it's all real numbers, which we write -infinity to infinity. And the range from the lowest to the highest, the smallest we went was -1, the highest we went with +1. Both of those are included, so we put square brackets. The general form for a trig function is y equals a times the function. I just chose to put sine in there. And then the quantity of bx plus c. The values of the a, the b, and the c have different effects on the shape and the location of the curve. The value of a in the general form of a trig function tells the amplitude of the function. For our first example, we are going to put using an a into practice. So we are going to graph for our first problem y equals 4 times the sine of x. Anytime you have a coefficient out in front of the function, this changes the amplitude. What this means for this problem then is that we have an amplitude of 4. When the only change to the function is having the number out front changing the amplitude, the angle measures that you use will not change. So we'll have 0, pi over 2, pi, 3 pi over 2, and 2 pi. What is different is that our highest number is 4 and our lowest number is -4. This is where you have to know your basic functions. The sine function starts at 0, 0, then it goes up at pi over 2, back to 0, down, and then back to 0. And so the only thing that's different about this from the original sine function that we drew is that it goes higher and lower. On our second example, the only thing we have is the coefficient out front, which changes the amplitude. So because the number out front is a 1/2, our amplitude is 1/2. The highest and the lowest that we go is 1/2. Our coefficient is also negative, though. When you have a negative on the front, what this means then is that you must flip the function upside down when you graph it. Since we are doing a cosine function, our x-coordinates, or the horizontal coordinates, are staying as 0, pi over 2, pi, 3 pi over 2, and 2 pi. The high and the low numbers, instead of being ones like the basic graph, are 1/2s. Think back to the basic cosine graph that we learned. It started up at 1. So because we have to flip this one, this is going to start down at the negative 1/2, then go to 0, then go to positive 1/2, back to 0, back to negative 1/2. So here is the graph of negative 1/2 cosine of x. The value of b in the general form of a trig function affects the period of the function. To find the new period length when you have a value of b in your trig function, you take the standard period length for that function, which if it's cosine and sine is 2 pi, and divide it by b. Our first example for how we change period length is the function y equals the sine of 2x. What you need to notice here is that the 2, what's right in front of the x, is b. So now, in order to find the period length, we take the standard period length. Well, this is a sine. Sine function has a standard period length of 2 pi. And we divide it by whatever b is. Our b is 2. So 2 pi divided by 2 simplifies to be pi. What this means then is instead of taking 2 pi to go through one full cycle, one through full period of our function, it's going to happen in only 1 pi. Think back to our original graph of the sine function. We said that to go through a full cycle took 2 pi, and we broke that up into 4 equal parts. We started at 0, but then we had pi over 2 pi, 3 pi over 2, and 2 pi, 4 equal parts. Those 4 equal parts that a period is divided into are called the increments. To find the increments, you always take the period length that you just came up with, in this case it was pi, and divide it by 4. So for the function that we need to graph now, our increments are pi over 4. We did not have an a on this problem. There was no number out front. So our amplitude is the basic 1. Our period is pi, and we said that the increments are pi over 4. That tells us what we need to count by. We are still starting at 0, and then to find all the rest of our numbers, we are going to add pi over 4. 0 plus pi over 4 is pi over 4. Pi over 4 plus pi over 4 gives me 2 pi over 4, which is pi over 2. If you wish to write it as 2 pi over 4, I am fine with that. 2 pi over 4 plus another pi over 4 gives me 3 pi over 4. 3 pi over 4 plus pi over 4 gives me 4 pi over 4, which is pi. Again, if you would like to write it as 4 pi over 4, that is absolutely fine. So now let's think about which function this is. This is a sine function. So sine's going to start at the 0, 0. At your first mark, it's going to be up at 1. Then it's going to be back at 0, down to -1, back to 0. And so now we have a new sine function with a period length of pi. On example B, where we are changing period length, the b in our problem is the 3. It's the number directly in front of the x. So to find the period length, you take standard period for a cosine function, which is 2 pi, and you divide it by your b. 2 pi divided by 3 is 2 pi over 3. That does not simplify. To help us with our counting, we are going to find the increments. Remember that to find the increments, you take the period length that you just found of 2 pi over 3 and divide that by 4. But remember, in fraction rules, that means that we are taking 2 pi over 3 times 1/4, because dividing by 4 is the same thing as multiplying by 1/4. So that becomes 2 pi over 12, which simplifies to be pi over 6. So pi over 6 is how we will need to count when we are setting up the labels on our graph. Because there was no a on this problem, our high and low are going to be 1 and -1. Our label will start at 0, like always. We're going to count by pi over 6's. So our first label will be at pi over 6. Now for the second label, you're going to add pi over 6 to pi over 6. That gives you 2 pi over 6, which you may use. I'm fine with that. And that simplifies, if you'd rather use the simplified version, to pi over 3. Add another pi over 6 to that, you're going to get 3 pi over 6, which simplifies to be pi over 2. Add another pi over 6 to that, you're going to get 4 pi over 6, which simplifies to be 2 pi over 3. Now we have our 4 equal parts, and if you'll notice, it's actually 5 label numbers. This will always be the case. In order to create 4 equal parts, you must have 5 total labels. Remember which function we are doing. We are doing the cosine function. The cosine function starts up. So we're going to start up at 1 and then go to 0, down to -1, back to 0, back up to 1. And so when we connect our graph, there is our cosine function. Notice that our ending label, 2 pi over 3, was the same number we got for period up here. That better happen or you've got some problems. On example 3, we are going to put both of our changes to a function into play at once. Notice that we have an a of 1/2. So what that means then is that amplitude is 1/2. We have a b of 4. So what that means is that our period, we're going to take standard period for cosine, which is 2 pi divided by 4, and that simplifies to be pi over 2. Always go ahead and find the increments. You will find that to be very helpful. So your increments, you take your period length that you just found of pi over 2 and divide by 4, or if it's already a fraction, multiply it by 1/4. This will give me pi over 8. So now I know how I need to count as I'm setting my graph up. Let's put all of this into place now. Our amplitude, our high and our low numbers, are 1/2 and -1/2. Our period is pi over 2, but what we really want to use is pi over 8 as our counter. So we're going to have 0 that we start at. We're going to add pi over 8 to that. Well, that puts me at pi over 8. Pi over 8 plus pi over 8 gives me 2 pi over 8, which equals pi over 4. 2 pi over 8 plus pi over 8 gives me 3 pi over 8. 3 pi over 8 plus pi over 8 gives me 4 pi over 8, which simplifies to be pi over 2. Have we got 5 marks? Yes. Did we end at the correct period length of pi over 2? Yes. So now we're ready to put our graph into place. Check which function it is. It's the cosine function. The cosine function always starts up, and then you go to 0, down, back to 0, up. So here is the graph of our cosine function. In trig functions, a horizontal translation, a horizontal move, is called a phase shift. To find phase shift for your trig functions, you will do the opposite of c divided by b. Our first example involving a phase shift is to graph the function y equals the sine of the quantity x plus pi. Let's recognize here that a is 1. There's no number showing out front, so it's assumed to be 1. B is the number in front of the x. There's nothing showing, so that too is a 1. The c in this problem is pi. So if we do each of the parts that we've talked about and how they are affected by the a, b, and c, amplitude is just going to be 1. Our period is going to be standard period length of sine is 2 pi divided by your b, which is just 1. So our period is going to be 2 pi. It's going to be a standard period length. So the increments then, if you take 2 pi and divide it into 4 equal parts, you're going to get pi over 2, like the standard graph. The new thing here is the phase shift. We do the opposite of our C. So we're going to do negative C over B. So our phase shift is going to be negative pi. What that tells us is we're going to take our basic sine graph and move it left pi. What will be very helpful for you when you are doing a phase shift is to get a common denominator for phase shift and increments. Well, increments are in pi over 2s, and the phase shift we could think of as negative 1 pi. How can we write negative pi as something over 2? We could think of it as being negative 2 pi over 2, because 1 is always the number over itself. Now that we have all of the parts found, we can go ahead and start putting everything together and create our graph. We know the amplitude is 1, so our labels on the vertical axis are going to be 1 and negative 1. Don't worry about period until after you've actually completed your graph. Use your increments and your phase shift to start putting the graph into position. So instead of starting at 0, because we have a phase shift of negative pi, we're going to take that whole graph and move it left to negative pi. So that means we're going to start at negative pi instead of at 0. Now remember that this is negative 2 over 2. And we want to add 1/2 to do our increments. So negative 2 over 2 plus 1 over 2 is going to give me negative pi over 2 for my second label. Negative pi over 2 plus pi over 2 puts me at 0 for my next label. 0 plus pi over 2 puts me at positive pi over 2 for my next label. Pi over 2 plus pi over 2 is 2 pi over 2, which is pi. And now I have my 5 labels, which have created 4 equal pieces. If you check this, to the left we've gone pi, to the right we've gone pi, that's a total of 2 pi. So is my period length 2 pi? Yes. Check that when you're done to make sure that everything has worked out okay. Remember what kind of function this was. This was a sine function. The sine function starts at 0 always, then goes up, back to 0, down, back to 0. And so this is our sine function with a horizontal shift of negative pi. For example 5, we are going to graph one period of the function y equals negative cosine of the quantity 2x minus pi. Again, let's find the a, b, and c to help us figure out what each of our pieces are here. A, in this case, is negative 1. B is 2. And c is negative pi. So in looking at this then, amplitude, because the number is 1, the amplitude will still just be 1. But it was negative, so we are going to have to flip this function. Period. We take standard length, 2 pi, divided by the b in the problem, which is 2. So period length for this function will be pi. increments. Take the period length you just found of pi and divide it by 4. So our increments are pi over 4. We need to count by pi over 4s. Our phase shift. We need to do the opposite of c. Since our c is already negative, we need to do positive pi over the b, which is 2. Remember what I talked about earlier, that you need a common denominator for phase shift and increments. So we're going to think of phase shift as 2 pi over 4 so that we have a common denominator with our increments, which are pi over 4. Let's put all of these parts into play and create our graph. Our amplitude is 1, so our vertical labels are 1 and -1. Our phase shift is pi over 2, or 2 pi over 4, whichever way you want to think of it. What that means is, instead of starting at 0, we are going to start at pi over 2. Now, remember, that's the same thing as 2 pi over 4. And to find our remaining labels, we need to add pi over 4s. So 2 pi over 4 plus pi over 4 puts me at 3 pi over 4 for label 2. Add another pi over 4. You will be at 4 pi over 4, which is just pi for label 3. Label 4 will be 5 pi over 4. And then label 5 will be 6 pi over 4, which simplifies to be 3 pi over 2. Let's check ourselves real quick. If I take 3 pi over 2 minus pi over 2, take the ending minus the beginning labels, I will get 2 pi over 2, which is pi. So did I get the correct period length? Yes. Now let's think about which function this is. This is a cosine function, which normally starts up. But because this one was negative, we have to start down. So at our first mark, we'll be down at -1. Then we'll go to 0, up to +1, back to 0, back down to -1. There is our 1 period of this cosine function. The last example that we are going to do with sines and cosines is y equals 2 times the sine of the quantity 3x plus pi over 4. A in this problem is 2, B is 3, C is pi over 4. So amplitude comes from the A. Amplitude's going to be 2. Period. Take standard period, which is 2 pi, divide it by your B, which is 3. So the new period length for this problem is 2 pi over 3. For the increments, we're going to take that period length that we just found of 2 pi over 3 and divide by 4, or since this is already a fraction, we're going to multiply by 1/4. That's going to give us 2 pi over 12, or pi over 6. Phase shift. We're going to do the opposite of our C which is negative pi over 4. And we're going to divide that by the b, which is pi over 3. Well, that becomes negative pi over 4 times 1/3, which gives us negative pi over 12. So this graph is going to, instead of starting at 0, move left pi over 12. Notice that our unsimplified version of the increments was 12ths. So I'm going to use that version instead of the simplified version. So there is our common denominators, which are going to be very helpful for our graph. Putting the graph together, our amplitude is 2. So our high is 2, our low is -2. Our first label needs to move left from the 0, means to go to negative pi over 12. Now to find the rest of our marks, we are going to add 2 pi over 12 to that. Negative pi over 12 plus 2 pi over 12. Think about that. Negative pi over 12 plus 2 pi over 12 is going to give me positive 1 pi over 12. So our second label will be positive pi over 12. Now do positive pi over 12 plus 2 pi over 12. That's going to give you 3 pi over 12, which is pi over 4. If you want to write 3 pi over 12, I'm fine with that. 3 pi over 12 plus 2 pi over 12 puts me at 5 pi over 12. And then add 2 more for your fifth mark, you're going to be at 7 pi over 12. This is a sine function, so the first point is always at 0. Be careful, you are not using the y-axis this time. I think this is the first graph where we are not using the y-axis. Our second mark is up at 2, then we are back to 0, down to -2, back to 0. And here is our sine function.